Nice worded question now with a biased dice. And we've got probabilities. Well, we know that the probabilities for each of these, for 1, 2, 3, and 4, it tells us that each of them is 1/8. But we don't know what the 5 is, and we don't know what the 6 is. I can't put X and X because I don't know that they're the same. In fact, they probably won't be. But we do know, we'll do another column first, shall we? Do the other row first. The X times P column there, so I've got 1/8, 2/8, 3/8, and 4/8. And there we've got 5A and 6B. So building the simultaneous equations, this row has to equal 1. So that just gives me A plus B is 0.5. And this row we've been told that the expected value of X is 4.1. So that gives me 5A plus 6B. Now how many eighths have we got altogether there? 4, that's 10/8, so 1.25. Take 1.25 away from that, gives me 2.85. Let's run that in the calculator again. So I've got 1, 0.5. Sorry, you can see that. And 5, 6, 2.85 to give me that the probability of getting a 5 was 0.15 and the probability of getting a 6 was 0.35. There's a second part to this one, isn't there? The dice is rolled 10 times. Calculate the probability that the dice lies on a 6 at least 3 times. So have you studied binomial distributions yet? So X, I can't use another X, can I? So let's use Y. Y equals the number of 6s obtained. The numbers of 6s rolled. And you'll either get a 6 or you won't. So Y is a binomial, excuse me, BIN, I always do it, but I was taught like that. Y is a binomial, we're rolling it 10 times, and the chance of getting a 6 on one particular roll is 0.35. And the question asks us, find the probability that we get at least 3, so that is greater than or equal to 3. And again, we have a calculator that will do that. So into our menu, we're going into our distributions menu here. The distributions menu for a binomial, and we want the tail greater than or equal to. Just check that is an or equal to. We want an or equal to as well. We want it greater than or equal to 3. We're playing 10 games, and the chance of getting the 6 was 0.35. And so it tells us that the answer is 0.7383. I'll do some more on these later, but it hasn't rounded that up. It's always interesting to spot that this is a truncated number and this is the full number there, which I got by pushing options F1. But it doesn't matter because in most stats we only want it to 3 figures anyway. So 0.738 is my answer there.